So for those watching the recording, we're kind of learning how to use our graphing calculator. So we just graphed y equals x squared. Now on the same window, what I want you to do is go to y equals, go back to y equals, arrow down to y2, and now we're going to graph, what was it, x squared plus 3. So we're going to graph x squared plus 3. So everyone type x squared plus 3. How is this going to, before you graph, how is this going to change your graph? What do you think it's going to do to the original? It's going to go up 3. It's going to shift the graph up 3. So go ahead and hit graph and let's see if you're right. Yay! Does everyone see that? You got it? Good.
How do we go back down from it being big?
How do you go? If you want to just go back to this window, you can always hit zoom 6 and it'll take you back to this normal window. Okay. All right, now we're going to do the other one. Go back to y equals. Go down to y3. And we're going to do x plus 3 quantity squared, so we need parentheses. The parentheses are down here. They're like right above the 8 key. So you do parenthesis, x plus 3 parenthesis, and then you square it, and then you hit enter. So how is this going to move our graph? To the left 3. All right, let's graph and see. You don't think these have what? Oh, they do. It's they're right.
Yeah. So if you want to get rid of the ones in the back, like if you just want the one that moves to the left.
Oh, okay, guys, I'm going to show you something that I did not show third because they didn't ask this question. It's a good question. So what Boobin just asked was, hey, what if I just want to see the new graph and not the 2 originals? But say I want them to kind of stay. I don't want to have to retype them again, but I don't want to look at them right now. So if I'm on my y equals, do you see right here, like in between the y and the x, there's this like highlighted equal sign? If I arrow over on top of it and hit enter, now it's not highlighted anymore. And now that equation will stay there, but it's not going to graph. Yeah, I'm going to get rid of these 2 and just have this one. See, and now they're still in the y equals editor, but they're not graphed. Is that what you were asking?
Yep.
Okay. I want to show you one other little trick. So if we go back to y equals, I'm going to turn x squared back on. So I'm just going to hit enter again on that equal sign and just have these 2. So last unit, does anyone remember what we studied? You took a whole test on it. Okay, that was your take-home test, but what did we call that whole thing? Systems of equations, right? And when you're graphing a system of equations or when you're solving it, what you're actually finding is where the 2 graphs intersect. Does that ring a bell? Where they cross? Okay. So say I wanted to find, see this point right here where these 2 graphs cross? Say I wanted to find that point on my calculator. So see here next to trace, right above it, there's a blue menu that says calc. Hit second calc. Or you could just watch me do it, because you might still have 3 graphs on your screen. Look at option 5. It says intersect. You hit enter on that, and it's going to say, what is the first curve you would like to look at? And you just hit enter. What is the second curve you would like to look at? And you just hit enter again because it's on your other one. Take a guess. It never cares where the guess is unless there's multiple answers. So you just hit enter again. And look at that. There's my point of intersection. Negative 1.5, 2.25. Isn't that nice? No? Yeah? I like it. Okay. There's one other little thing I want to show you, which is the trace button. So if I want to know y value, you know what, there's a couple things I'm going to show you. If I want to know any y values, once you hit trace, you can type a number. Like just type 2 and hit enter, and it's going to plug in a 2 for x and tell you your y. Right? If you can keep doing it, like type 3 and hit enter. You don't have to like do anything in between, and it'll tell you your y. Right? If I type -4, enter, there's my y. Oops. So that's what trace does. Just type in any x value and it gives you the y value. The last thing that I'm going to show you is if you want a table. So it's only going to give you tables for the ones that I've highlighted on my y equals. So I only have y1 and y3. But this table gives you the y values for, you know, every x value integer. In case you ever wanted a table. All right. Any questions on the calculator? We're going to do more with it, but that was all we're going to do today. It's like a little intro to calculator day. Okay, good. All right, turn them off. Oh, by the way, if I want to get out of this menu or whatever I'm doing, say I'm on a graph and I want to get out of this, you have to quit, which is second mode, and it'll quit you out and take you back to the main screen. So you have to quit to get out of graphing, and then second off to turn it off. All right. Today we're doing section 3.5, which is translations and quadratics. Translations and quadratics. Once we're done with this lesson, I am going to hand out a new calendar. I'm going to hand out your homework assignment, and I'm going to give you a quiz that we're going to take today. I know a whole bunch of you are probably going to be out tomorrow, so I will also hand out tomorrow's work for those of you who are going to be out tomorrow. I think it's a week from Friday. Mm-hmm.
Cool.
I'm sorry?
Like assignments?
Yeah. I think Friday is Friday the 13th, too.
Whoa, yeah.
Okay, so we're all good, like.
Yeah.
I mean, it's gonna happen.
All right.
Miss Park.
Yes.
Can I take my test?
Can you do what?
Can I take my test tomorrow? After school?
Yeah, you just have to sign up in the test center.
Oh, alright.
Yeah. I don't proctor tests. Like, I'm not going to sit there and watch you test. It has to be in the test center. Yeah. Yep. So just go down there and sign up after school today or sometime, and then I will bring a test out. All right. So on this screen, the main two things I want you to learn from this screen are what is a vertex and what is an axis of symmetry. The vertex is a point. This point right here, which is what I kind of think of as the bottom of the parabola, it's really the point where the parabola changes direction, either from decreasing to increasing or increasing to decreasing. But you can think of it as the bottom of the parabola or the top if the parabola is flipped upside down. Anyway, that point is called the vertex. So, for example, for this parabola, which is kind of the standard parent function y equals x squared, the vertex is the point 0, 0. The vertex is an ordered pair. It's the location of that point. The axis of symmetry is a line that splits the parabola into two mirrored halves, right? To two equal halves. That's called the axis of symmetry. For all the parabolas that we do in this class, at least in this unit, they're all going to be like vertical parabolas, opening up or opening down. None of them are going to open sideways. They're all going to open up or down. So the axis of symmetry is always going to be a vertical line. What does the equation of a vertical line look like? Is it x equals or y equals? It's x equals, right? So this line will always pass through the vertex. So the equation of the line of symmetry or the axis of symmetry is always x equals whatever the x coordinate of the vertex is. It's always x equals whatever the x coordinate of the vertex is. And we're going to write that out in a few more slides, but you're welcome to write it down now. Okay, any questions on line of symmetry or axis of symmetry or vertex? Comfortable there? Good. All right. Okay, so in this screen, we're going to see what you remember from yesterday. Now, there's something a term I need to teach you, which is parent function. A parent function, the parent quadratic function, is y equals x squared. A parent function is the basic form of a function before it has been transformed in any way. So if you take a function with no translations or reflections or dilations or rotations, you just take that function as it is, that's called a parent function. Once you start moving it around or stretching it or shrinking it, it's no longer the parent function, it's been transformed. So the parent quadratic function is just y equals x squared. Okay. So on these three graphs, the parent function is in black. And then what you have is you have a transformed function in red. What your job is as a group, just in your desks, we'll do something on whiteboards in a minute, but as a group, your job is to see if you can write the equation of this transformed graph. Now, I don't know if you remember it or not, but if we transform, if we translate means shift. So if we shift up or down, are we adding to the x value or the y value? To the y value. If we shift left or right, are we going to add to the x value or the y value? X. When you shift up or down, the sign is what you think it should be, positive up, negative down. When you shift left or right, you have to do opposite. Take a second in your group, see if you can write an equation for each of these three red graphs. I'm going to give you a couple minutes to talk about it. So for this first one, just tell me in words, how is this changed? How is this shifted? Down by how many? 4. So we're shifting this down 4, which means we're going to subtract 4 from our y value. So this equation, x squared minus 4. X squared minus 4. When you shift up or down, you add or subtract to the, by the way, when I say add or subtract to the y value, I don't mean on the left side. I mean on the right side, and that can be kind of confusing. I want to make sure you all understand something. If I say y equals x squared, that equals is the same thing as saying is, right? That means y is x squared. Like these are the same thing. So when I say add to the y, everything I do is always going to be the right hand side. So even though it's like, wow, but my y is over here, this is also y. I'm subtracting 4. So I'm subtracting 4 from the y. So when I say from the y, I mean on the right hand side, but on kind of like the outside of your function. So think outside is like to the output. So I kind of always thought output, outside, they kind of go together. If I was adding or subtracting to the x, then it would be in here, in with the x, in with the input, right? That would be to the x. To the x, to the y, to the input, to the output. Does that make sense? Inside, outside, All right. Okay, so for this next one, how is this thing shifted? Up 1, right? Shifted up 1. So are we going to add or subtract? Are we going to add or subtract to the input or the output? Output, again. So we have x squared, and then what do we put? Plus 1. This guy right here, how is this shifted? To the right 2. So am I going to add or subtract to the input or the output? Input. And if I want to move to the right, I do the opposite sign. I subtract 2. No, there's another reason. It doesn't even matter. It doesn't have to be x squared. It can be any function, and it's still opposite.
You know why?
There's a reason why when we get, but I don't want. Yeah. There is a reason.
Yeah.
Okay. If we made a table, I think it would make it easier to see. But anyway, okay. So that's all I want to do with that. Unless there are questions, we're going to do this again in just a minute. Okay. All right. So for these 3, I want these 3 on your whiteboard, the 3 equations. However, before you jump up and do them, so this one is fine. It's a left or right shift. But E and F have shifts both left, right, and or up and down, right? So they have combinations. See what you can come up with and see if you can write equations for D, E, and F on your whiteboard. For this first one, we are shifting in which direction? Left, right, up, or down? Left by how many places? 4 places. Which means, are we going to add or subtract to the X or the Y? We're going to add to the X to move it to the left. Do I have to do anything to the Y's? No, because it didn't shift up or down. All right, by the way, I have to apologize in advance. I am so deeply ingrained with the word shift for translate. So if you are ever, just so you know, when you are, we're going to do this in a minute too, but when you're taking a quiz or a test and it says describe what's happening in words, if you say that this graph shifts left by 4, right? That's fine. Or if you say translates, it's the same thing. Just know translates is the correct mathematical term. Shifts is the one that I have always used just out of old habit. By the way, so a little side story. So I used to teach with a teacher who was British. And hi, Mr. Jones. So he used to not say, like, whenever I would get his students in my class, if we were shifting horizontally, they would all correct me and say, that's not a shift, it's a shunt. And I would say, what's a shunt, right? And the first time I ever heard that. Have you guys ever heard the word shunt?
No.
No? So I had never heard it either. So I always just say shift, right? And that's what most people in the United States say is shift. But he would always insist on shunt. And then I was watching Thomas the Train. Have you ever watched Thomas the Train? Do you know what I'm talking about? Okay. All right. So I was watching that with one of my boys when they were little. And when they sing the song, the opening song, so the opening song, it goes like, there, 2, there, 4, there, 6, there, 8. The next line is shunting trucks and hauling freight. They're shunting the trucks, which means they're like pushing them horizontally. And so then I'm like, oh my gosh, it says the word shunt right there in context, right? So anyway, so he was right, it's shunt, but I don't say shunt, I say shift. So anyway, all right, so shifts left 4. This one, we're going to shift left 2 and up 2, right? So the left 2, what do I put in here to get a plus 2, shifts it to the left. And then out here, I want to shift up 2, another plus 2. Have you all kind of like made that connection that this guy, when you're out here, adding goes up, but when you're in here, adding goes left? Okay? Okay. All right, last one. We're going to shift to the right 4 and You could say it down 2, right? So how do I shift to the right 4? What goes in here? X minus 4 goes to the right, and then down to minus 2. Notice that these are all still squared. They're all still quadratics, right? So you can't drop the squared part. That's important. That's what makes it the parabola shaped, right? Is that squared thing. Okay? All right. Any questions on writing these equations of translations? All right. Moving right along. So here's what I want, and this can just be on paper. So we have 4 equations right here. Graph A is the parent function. So graph A right here, this is the parent function. Well, I'm going to even write it out for you. A has an equation y equals x squared. It has a vertex right here of 0, 0. And it has an axis of symmetry of that vertical line that goes through the vertex, x equals 0. What I want you to do right now in your groups, just stay sitting for a few. You just stood up. Okay. Is see if you can find equations for B, C, and D along with the vertices and the axis of symmetry. So take a couple minutes.
Okay, you're right.
So for graph B over here, we are taking the parent function and we're shifting it 1, 2, 3 places to the right. So my equation, to move to the right, I'm going to have inside the parentheses x minus 3. What is the vertex of this parabola? 3, 0. And what is the axis of symmetry?
X equals 3.
X equals 3. All right, let's do graph C. So graph C is this one right here, which is 1, 2, 3 places up. So for graph C, would I be adding to the x or the y? The y. So I write x squared, and then on the outside, plus 3. Do you understand the difference when I say between inside and outside? Inside is you're going to have parentheses with your x, right? Okay. All right. What is the vertex of graph C? 0, 3. What's the axis of symmetry?
X equals 0.
X equals 0. Last one. Graph D. We have shifted left 4, down 3. So we're going to have y equals x.
Plus 4.
Is it minus 4 or plus 4?
Plus 4.
Plus 4 goes to the left, squared, and then we want to go down 3, minus 3. All right. Okay, so what is our vertex?
-4,
-4, -3. And what's our axis of symmetry? X equals -4. All right, we're going to write some generic definitions. Are there any questions on these? How'd you do? Yeah? Pretty good, pretty good. Marcus in the back, how are you doing? I said, how are you doing? Yeah? Okay. Very good. All right. If we had to write kind of something in general, that's what this is talking about here. Is there a general way to write the equation of a quadratic? Is there a general way to write the vertex? So what ends up happening is if your vertex, oops, I can't even write the word if, much less any of the rest of this. If the vertex is HK, which is the most common way of writing the vertex of a parabola. So don't ask me why they chose the letters H and K. They just did. Don't know why. H for happy, K for koala, right? Okay. Okay. All right. If the vertex is HK, then the equation is y equals x minus h, because you have to go in the opposite direction, squared plus k. So x minus h squared plus k. So if I'm looking at this equation right here, I know without even a graph that my vertex is at -4 because I changed the sign, and then -3 because I keep the sign, right? So -4, -3 would be my vertex. And then my axis of symmetry would be x equals h.
And H is
For this one, h is -4. Always the opposite.
okay.
Wait.
Yes.
So it's always going to be x minus h.
So x minus h tells you to take whatever your x coordinate vertex is and change the sign. So for example, for graph D, our vertex is -4, -3, right? That's where that point is. But our equation is x plus 4 squared minus 3, right? So when you're writing your vertex and you're looking at this, you do the opposite sign.
I got it.
X is always going to be opposite. Why do you get this state? Hey, look at this one. Look at letter C. There's no number with the X, and it says our vertex is 0, 3. Does that make sense? Yeah, it's the same thing as like x minus 0. Like if there's nothing, if it's just x squared, it's the same as x minus 0 squared. So the x coordinate of vertex is just 0. There's not a number. Okay. All right, moving on. Okay, it's time to learn how to graph. I am going to walk you through this first graph, and then I want you guys to try the next one. So when you are, and it's actually important, I don't want you to just do a swoosh with a rough shape, because when we get into dilations and reflections, those individual points are going to matter. So I am going to check to make sure that you've plotted several points, but I don't want you to have to make a table every time. So I'm going to teach you a trick for graphing a parabola. All right? So for this first one, this is your parent function, y equals x squared. We want to translate this vertically -5. When they say translate vertically -5, that means shift down 5. Do you all understand that? Kind of a weird way to put it, but shift down 5. All right. So 1, 2, 3, 4, 5. There's my new vertex. When you're drawing a parabola, first thing you always do is plot the vertex. Okay, good.
You guys know what horizontal?
Horizontal like the horizon.
Gotta double check.
Okay. That's okay. That's good. All right. So now stay with me. This is kind of important. Are you ready? When you want to graph a parabola, so you start the vertex, go over 1, up 1. And you could do that in both directions. All right, everyone over 1, up 1, both directions. Now, sit on the new point here and go over 1, up 3. And you could do that in both directions. Now, I'm going to graph another pair, and I want to see if you can recognize the pattern. So I went over 1, up 1. I went over 1, up 3. If I were to do it again, I'd go over 1 and up 5. And if I were to do it again, I go over 1 and up 7. It increases by odd numbers each time. But honestly, you don't have to, as long as you have these points, these 5 right here, the vertex over 1, up 1, and then from there over 1, up 3, and then you connect with a nice swoosh, right? That's what I'm looking for. Those 5 points. So over 1, up 1, and then from there, over 1, up 3. All right. So I want you all to graph if the parent function was translated horizontally +3 units, which means to the right 3. So go ahead and sketch a graph of the same parent function that's been translated right 3. Take a minute on paper. You just but I want some points. The point 0, 0. This point, someday I will learn this this point right here, the point 0, 0, has a name. The name of that point, so the point 0, 0, is called the origin. The origin. Whenever you see something that refers to the origin, it means the point 0, 0. It's like the origin of all graphing things. So the origin of all things graphing. So the point 0, 0 is called the origin. So last night when your homework said rotate about the origin, it meant rotate it around that center point, 0, 0, right? So that's called the origin. If you don't know, really important math term, you're going to hear it a lot. So the origin. All right. Look. Yeah, I'm just going to erase this. Okay, so now we're horizontally 3 units, so I'm going to go to the right 3. So if I go over 1, how many do I go up for my first point? I go over 1, up 1, and then same thing this way. Now if I go over 1 from there, how many do I go up? 1, 2, 3. 1, 2, 3. Yes, if you were to do it again, it'd be 5. By the way, do you understand mathematically? I'm just going to show you something to help you connect this. So this is y equals x squared, right? Number squared. The y values are all squares, right? If we're talking about the integers, it's all the perfect squares. If I list the perfect squares, 1 squared is 1. What's 2 squared? 4. Actually, let's start with 0. Okay. What's 3 squared?
9.
What's 4 squared?
16.
What's 5 squared?
25.
Right? Okay, and then you keep going, right? What's the difference? What if I did 1 minus 0? What do you get? What's 4 minus 1? 9 minus 4. Whoa, right? It's how far do you step from one y value to the next, right? Now, there's a reason for this, but I don't want to teach it to you right now because it's so completely off track of what we're doing. But anyway, but that's why you do that when you sketch your parabola. Why do you go up? Okay. All right. This you don't even have to write. We've already got it in our notes. So in general, what is the equation of the parabola formed when the graph of y equals x squared is translated horizontally h units and vertically k units? Y equals quantity x minus h squared plus k, right? So that's all this is doing. It's just reinforcing x minus h squared plus k.
Is that the equation you want to show us? Or like it was
Maybe,
there?
yeah. I think that was on all the screens yesterday. It was an HK form, a vertex form for the equations, yeah. Okay, we're going to do this. Should we do this now or do this in a minute? Let's do the next part first. Okay. So we have 2 screens left, kind of unrelated to what you've been doing, and then I have to add a 3rd screen because of some stuff that came up on your quiz. So we're going to learn how to solve a quadratic equation without factoring. Okay? So we're going to learn how to solve a quadratic equation using square roots. So when you want to, and the only time you're allowed to do this is if there is only one, like if you look at the equation and there's only one x and there's a squared in there somewhere, right? If you have x's in multiple spots, you're in factoring mode. But if you only have one x and if there's a squared, it's a quadratic, you can do this method. And the first step, and I'm just going to write down the first step, is you're going to isolate the squared term. What does isolate mean? Get it by itself is perfect. Very nice description for isolate. All right. And then you're going to square root both sides. And don't forget the plus or minus. So we're going to walk through this, okay? So we're going to get a squared term by itself. And then we're going to take a square root of both sides. I am going to show you why this works in just a second. But for this first one, in order to get the squared term by itself, what am I going to have to do first? How about add 10?
Oh, yeah.
Okay, all right. Okay, add 10. So we have, I add 10, and I have x squared equals 49. Is the squared term isolated? Yes. I'm ready to square root both sides. I'm going to go ahead and write a square root here. And let's see if I can let me break this up. Nope, I'm going to erase and move it over. Okay. And I'm going to put a square root here. On the right-hand side, you have to put a plus or minus. There's a reason for this. All right. Does anyone know what the square root of x squared is? It is x, right? Because if you take something and you square it and then you square root it, you're back to where you started. So the square root of x squared is x. Anyone know what the square root of 49 is? 7. So this is plus or minus 7, and you're done. Now I'm going to show you why. So right here, right from the beginning, instead of adding the 10, if I subtracted the 39, right, normally for quadratics, what do? We set them equal to 0, and then we do, what's our favorite F word?
Factor.
We factor, right? Okay. So when you factor this is called a difference of squares, 2 terms with a minus in the middle. X, 7, 7 plus minus. So when we solve, right, you set this factor equal to 0, you set this factor equal to 0, and you get x equals -7 or +7. This plus or minus is a shorthand for writing +7 and -7. So it's saying x is both of these values. So this saves you from having to do this. Okay, which you could do, right? If you want to do this, it's fine. Totally correct, right? Nothing wrong with setting equal to 0 and factoring, right? Okay, but the other way is a little bit faster. So next one, letter B. Is the squared term isolated? Yes, it is. Because the whole thing's being squared, right? So for this problem, you have to start by square rooting both sides. What do I have to put on the right-hand side? Plus or minus. If you aren't in the habit of doing that, don't do this method. You're going to get them all wrong. Quadratics have 2 answers. They have to have 2 answers unless it's the same answer repeated. So anyway, so make sure you've got that plus or minus. All right, what's the square root of x minus 3 squared? X minus 3. What's the square root of 16? 4. Now, stay with me. When I add 3 to both sides to solve for x, so you can put it over here. I personally would suggest you put it in front of the plus or minus, and I'll show you why. Because we're not done. You can't leave an answer like this. You have to give me your 2 values of x. Fully simplified. So, x is either 3 plus 4. What's 3 plus 4? 7. Or 3 minus 4, which is -1. And there's your 2 answers. How could we check to see if those are right? Plug it in where? The original equation, right? Plug a 7 in here. What's 7 minus 3? 4. What's 4 squared? 16. Is that true? -1. What's -1 minus 3? Negative quattro, right? What's negative quattro squared? 16. Yes. Does that work? Yes. Okay. All right. So yes, that's how you get it. I want everyone to try this one start to finish. start to finish. See if you can solve this last equation, start to finish. Yes. All right, so what do I have to do first? Divide by 2. What's 72 divided by 2? 36. Have I lost everybody? Yeah? Square root, put a plus or minus. What's the square root of x plus 1 squared? What's the square root of 36? 6. Subtract the 1.
Yeah. Oh, you're right.
What's negative 1 plus 6? What's negative 1 minus 6? Negative 7. All right. Okay. One more thing we have to learn today. It's an introduction. And then we're done. Okay. And then we'll be free to do homework and quizzes and all that kind of stuff. So I have to introduce you to piecewise functions. So kind of just chillax for a second. A piecewise function is when you take multiple functions and put them together. Multiple functions and put them together. So for this function right here, this is one function. It's named f of x. It has 3 different pieces, but it's one function. So this first piece is the line 2 plus x. Now if I were to graph the line 2 plus x, it has a y-intercept of 2 and a slope of 1, and it would look like that. However, this line f of x equals 2 plus x is only valid for the x values from negative 2 to 1. This line only exists from negative 2 to 1. So, x equals negative 2, that's here. X equals 1, that's here. Any x value that's outside of that should not be on that graph. So this is the graph y equals 2 plus x from x equals negative 2 to x equals 1. Technically, this is the domain of this graph. Well, we say negative 2 to 1, but yes. Yeah, we always read low to high. Yes. All right. The next graph is the graph of y equals 3. Now, what kind of a graph is the graph y equals 3? It's a horizontal line. So we're going to graph the horizontal line y equals 3, but only from x equals 1 to x equals 2. So we go there.
But you
From
don't
1 to
circle
2.
that one.
Yeah, so what happens is, since we don't include the 1, we would normally put an open circle here, but it's filled in by this guy, so it really doesn't matter because they overlap. All right, the last one, if we simplify this, is kind of a convoluted equation, right? So 3 minus 2x plus 4, so this is negative 2x plus 7. So normally if I was graphing negative 2x plus 7, I'd go up 7 and then go down 2 over 1, down 2 over 1. So, except I want to start this at x equals 2. If you don't know how to start it without the y-intercept, you can do this, right? It's a line. If I plug in a 2, I get negative 4 plus 7, which is 3. So I know I'm starting at the point 2, 3. And then my slope is down 2 over 1, right? Oh, and then I stop because it stops at 3. So, okay. So, 3 equations. So this is y equals 2 plus x. This y equals 3. And this y equals this whole big conglomerate, which is negative 2x plus 7. And you simplify it, right? 2 plus x from negative 2 to 1. So I like to say this is what you graph, and this is where you graph it. Then y equals 3 from 1 to 2, and y equals this guy from 2 to 3. And that would be your piecewise function. This one right here, everyone, we're going to write this piecewise function. So the first thing I want you to tell me, take a second and just mentally think of the equation of that line. You should be able to do it without any writing or work at all. Okay, just the equation of this line. Okay, what's the slope? 1/3 x, what's the y-intercept?
2.
Plus 2. What x values are we graphing this for? From what to what?
-3 to 0.
-3 to 0. -3 plus negative x less than or equal to 0. The next one is a parabola. It's been chopped off, but it's still a traditional regular parabola, right? Up 1, over 1, right? Over 1, up 3. Normal parabola. The vertex has been shifted a little bit. If only we knew how to write the equation of a parabola. X minus 1 squared plus 1. Because we went right 1, up 1, right? Okay, what x's does the parabola exist for? 0 to 3. I'm just going to put less than and then less than or equal to 3. You can't have both of these with equals because then you would fail the vertical line test. You'd have an overlap. You'd have double answers. So if one of them's equal, and then the other one has to be not. So they kind of one fills in the other. All right, that is it. We are done with the lesson.